Okay,
Cool.
it's recording.
So eventually, we're gonna get you guys a browser on here, but for now, you're gonna use this building operation workstation 1.7 icon. It's also down here in the taskbar. I'm sure you guys have been showed this, but it's just pretty much that's what you're gonna use for now. Your password's up here. Username, password, BMS, # 2016. Just hit register later if you ever come into this window like this. But I'll always bring you up into this window. This is always the home screen. Just going to run through the architecture real quick. We'll go through the tabs. Out here on the right you have your wet systems, major information, your header pressure for your steam system, your supply and return temperature for your boilers, as well as your chillers. You just go over to the floor plan. Pretty straightforward. It's a floor plan. If you click on all these arrows, there's multiple options for each floor. And as you can see, the first floor only has floor plan and VAV, while the third floor, has floor plan, VAV summary, and isolation rooms. That's because there's only isolation rooms on the third, fourth, and sixth. And on the fifth, you have operation rooms. Anything that gets highlighted in red, you should be able to click. Get your floor plan for your fifth floor. You get your VAV summary. Everything's in numerical order. And then your operation rooms has the entire information, because you can get to these VAV boxes from the VAV summary, but you can only get to the...
He's fine.
Good? Alright. You can only get to the operation room summary like this through that operation rooms tab. This is the only way you can get to these. It's a more detailed page if you guys are looking for it, to see what's going on inside those rooms. But anyways, so that's pretty much the gist of it. Isolation rooms looks a little bit like the same thing as the operation. Isolation rooms look like the operation rooms. Go over to your wet systems. This should be all your chilled water, hot water, and steam system. There's multiple tabs for your chilled water. You have your schematic, which is just your piping layout. So here's your chillers. Follow the arrows. It goes out to your pump, your secondary pumps. It goes down to your data center as well as your MRI, but it also pumps it over to your AHUs. And then obviously returns back as the global return to the primary pumps, which pushes through the chillers again. If you guys ever wondering about how these things stage, here is the information how they stage up and stage down. It's just a written sequence of saying, all right, when your chilled water flow is greater than -10 GPM of 50 GPM, and any primary chilled water pump status is confirmed to be true, 1 chiller on. And then it will keep pushing forward onto 3 chillers. As you can see, you have a bunch of steps you have to go through. There's up timers, so when we turn on a chiller, they can only be up for a minimum of 15 minutes. And then when they're down, they can be off for a minimum of 15 minutes. Also, you have more information up here with your primary and secondary pumps, what your AHU valves are doing, because your AHUs are pretty much the primary cooling source for your entire building, with the exception of the data center having its extra, as well as the MRI. But that's for your tempered air. Also is the MRI room detail. Just has its own little graphic for it. Got your secondary pump. Pretty straightforward. We'll go into this detail a little bit soon. But comes in here from the main system, goes through a little tiny, I'm sure you guys have seen the heat exchangers down at B2.
So I had a question about this, the bypass valve, 100%. Do you want that?
Yeah, that's actually 100% closed.
Oh, it's closed.
It's closed, yeah. That's something that most of the bypass valves are 100%. When they're 100%, they're full closed. When you go the other way, they'll open. It's kind of backwards.
Right.
But it's just how these valves work. It's kind of weird.
Okay. But that's not like heat pumps though, right? Heat pumps 100% is 100% open, right?
If it was a heat pump, yeah.
Okay.
Just because of the action of these valves, the way they are, they spring open for safety reasons.
Now, if the system failed, do the whole system spring open and allow the pressures and things to subside, to not maintain that temperature?
if I remember correctly, and I'd have to look at prints, but if say this bypass, say we lost power to this system right here, the chill water system valves that for the main system will actually spring close, and your industrial water will spring open.
Okay.
And that's just a safety because it's just under the assumption that if you've lost power here, you've lost power everywhere.
Right.
So what it's going to do is it's going to rely on the city water to maintain that, at least
And still circulate the water.
still
right?
circulate and then dump. Hot water system, a lot more. It's a lot simpler.
That one, why I got a question, you know, for simple, why not? Those things, you know, we need to spend a lot of time to look at that one, why they try to understand. But the more important right now is the room, like a 6th floor, why they 03, room 03, 603, right? They say the temperature too hot. Okay, how we can adjust the temperature right here?
Okay, we'll get into that soon.
Okay.
I'm running through some stuff real quick,
Okay.
and then we'll be running through VAV operation and stuff like that as well.
Okay.
So the one thing I didn't look at on your chillers in the schematic, I forgot to mention up in the right hand corner here. You have the staging page, which will also take you to the same page that we clicked over here.
Where are we at right now? Wet systems, chill water, schematic.
Up in the right hand corner, there's the HLI detail page. This is all the information that comes in from the integration that Trane gives us. So it'll tell you all the run times on each compressor. It'll tell you the status of each compressor, if they're on or off, if it's an alarm, the inlet and outlet temperature that is coming from the chillers. So these are not our sensors, it's actually theirs. Status if it's on, and the mode if it's run or fault. And then obviously it's running capacity as well. And then you have just general chilled water system enabled, which that will probably rarely ever be off for you guys.
So 3 is off on this thing. Right?
3 is off just due to staging, because I believe chiller 1 is lead. And it looks like there's enough demand in the building that it needed chiller 2, so it turned on chiller 2.
What would be a manual way of turning on chiller 3 if we had to?
If you had to, you come in here, hit force, and then, oops, you clear that all out, and then write 3, and then hit OK. I'm not going to,
Right,
I don't
right.
want this to switch.
And then that would kick on 3.
That would kick on
Is that a
3.
manual,
These would still run for a short time because they do have a off sequence.
Right.
So they won't shut right off. They need to. These chillers will shut off. The valves will stay open to keep pushing through flow and kind of. That way, you're not just leaving cold water in the chamber. We're actually kind of bringing out all that cool. So yeah, this is the one I just forgot to mention. Is that the HLI detail page is just integration information that you get from the Trane chillers themselves.
This is Steve?
Steam
Right.
system's actually really straightforward compared to the hot water system.
We have a
sorry, I got myself there.
Oh,
You have 3
cartridge
boilers,
you
but
have to get
unfortunately
from,
we don't
Norris.
control the staging of these boilers. These are all controlled locally by Airco.
Sure. You
So
wanna
they do
come
their
down
own
there?
staging.
We have a
They
bunch
do
of
their
different
automatic
colors and
rollover,
stuff.
so it'll go.
And we actually
we
have a
absolutely
meeting right now, so
no control
Yeah.
of which boiler runs and which one doesn't.
maybe in an hour.
As well as these
Okay.
pumps. These pumps just run to their abiding boiler. So as you can see, boiler 2 and 3 are on, so you have primary 2 and 3 on. You have 2 secondary pumps that control to system TP. Excuse me. One is always enough for this. Pretty straightforward system. These boilers, we send them a set point, which is right here, the system set point. So currently we're still working with the manufacturer on the set point, so these things run to 180 right now. And we're working with them. I've made a phone call yesterday with them, so currently you can't control it with the set point, but in the future, when this is all said and done, you guys will be able to control the whole system set point through this point right here. But unfortunately right now, it's proving more difficult than anything. Over here in the right hand corner you also have the domestic hot water temp. That's just high temperature, low temperature. It'll pop an alarm in your alarm panel if it goes to too high or too low.
Can we adjust that?
What do you mean?
Like make it higher or lower?
The alarm point or?
Or the temperature of the water?
No. That's just strictly monitoring reasons, unfortunately.
Okay.
I think they just wanted a point for you guys to know that if it does fail, because that thing's all the way up in the penthouse. So it doesn't do
Right.
anything for you. The boiler HLI detail page is just like the chiller HLI detail page. It's just the points that we grab from the integration. So what it does, it tells you the firing rate, the flame strength, if it's in fault, inlet and outlet temperature coming from that boiler, as well as the run times on each. So as you can see, these two are pretty far behind on runtime to boiler 1. What's going to happen is these are going to run until it catches up, and then boiler 1 will take over. So these switch off the runtime on their own. Steam system, pretty simple. We only have commands and fault statuses on all 4 of these. We try to maintain 75 psi by starting these things. We don't control anything else on these things. We shouldn't have 4 on, but that's besides the point. You can control your lead steam boiler up here by selecting it, but it will rotate automatically anyways. You can see you're on stage 4 right now. There is a sequence to this, and on your HLI detail page, they're pretty simple points, but there's always one stage on, but these will tell you more details on what each stage is, and we'll go into more details about this as we go through the steam schematic. Like I said, I'm just doing a quick run through so you guys kind of see all the graphics right now. Humidifiers for the PACU and the 2 ICU rooms.
Where are those located?
These 2 are located on the 6th floor, and PACU is located on the 5th.
Like in the ceiling? Or?
In the ceiling,
Okay.
yeah. These 2 are, oh gosh, they're on the north side of the building, kind of in that corner with the sliding isolation room doors. They're like right around that nurse's station, while the PACU is right inside that room, just like above if you're looking from inside the room, the right door. Air systems, I'm sure you guys have seen this a lot over the past few weeks. Air handler 1, 2, and 3, and 4. Excuse me. Here, it's all your air handler information. Static pressure. You have all the exhaust fans that run in sequence with the air handler. They're all going to have tables on each air handler for this. So 2, 3, and 4. And these are the exhaust fans that if the air handler ever loses status, which is this point right here, if it gets turned off upstairs, or if you guys turn it off from here, all these exhaust fans will turn off, and you can just see a quick view right here. If you want more details, go to the exhaust fans page, and this is all the exhaust fans inside your building. You have what AHU also serves with it. Some obviously don't work with an AHU. They're kind of independent, standalone, and they're pretty much run 24/7. We got too far. This is the fan coil unit downstairs in B2, in that giant main electrical room. I'm sure you've seen it. It's up in the ceiling, kind of free hanging. Cool only. That's all it does. You have a switch here. We'll go over that when we get to it. Your set point's down here, and your room temp's over here. It just pretty much tries to cool to that point, and if it's not cooling to that point, then it'll just push air around pretty much. Here's another view, another way to get to the humidifiers if you don't want to go through the steam boilers. It's all through the air systems. This is just RF12. I think this is actually deleted. I don't think we actually have stuff for that. This is a quick pressure monitor look at all the pressure monitor page. As you can see, this one's an alarm right now because it does look a little high. That must be either someone going in and out. Looks like it just went out of alarm. I think it was you, Bob.
Yeah.
You were the gentleman asking about if we can change these from occupied or isolation, and
Right.
unfortunately, I don't think we have the access yet. I think we're working on it.
Okay.
But this is a good view to see of what room's occupied. If it's no isolation, it means they went up to the unit, hit it, told it, all right, I don't want you to go into alarm anymore.
Gotcha.
These 2 are still being worked on. These will be added in the future to this page because we're potentially adding another one for that floor. It's the IV prep room. which is within the pharmacy. Miscellaneous, it's pretty much self-explanatory. It's pretty much anything that doesn't fall under anything else. If you're building, this is generator status. You have generator common alarm, generator 1 status, as well as generator 2 common alarm and generator 2 status. If you guys ever have a generator go on and for some reason you're not sure why generator 2 is running, this point right here should be an alarm. It should say, hey, what's going on? And yeah, and that's pretty much explanatory for that. The mech room R05, that is the, it's the penthouse. I'll have to look into that, but I believe that is the actual penthouse room temp. If that gets too high, it'll alarm you guys here. I believe you have to go above 90 degrees for 5 minutes or so. Same with the elevator temp, room temp. This is just monitoring, nothing special about it.
So all 3 is just monitoring?
They're all monitoring. That's all they really do.
So we have no control?
They're just here to. Well, there is a elevator room temp. Oh, that's the one thing. There is a room. There is a system for the elevator room. It's called. Oh goodness, I can't remember the name of it. It's a small little train unit up above that, up on the roof above the elevator machine room. Yeah,
Right.
and it dumps down. And all it is a cooling only unit. We send it at a set point. Sorry.
Where can we view that one?
It's gonna go under air systems, and we have to add it. That's the one thing that we gotta switch out to RF12 for that. Fire system, it's just pretty much tells you if any of these pop an alarm or go on or off here. If you wanted to look at it on one point, you can look at it on our system. These 3 points will send an alarm to your console if they ever go into alarm.
You mean our simplex 5 panel?
Yep.
Okay. So it's like a redundant system besides, because simplex does that already. Right?
Yeah, I know. Pretty much.
Okay.
It's pretty much just there, so
Okay.
someone
So it's
wanted-
like one central to view everything.
yeah, someone wanted it, so
Yeah. No,
we got it,
it's
yeah.
good to know. 'Cause
Yeah.
then we have like, we got generator right there, we got fire system right there, we got oxygen right there. So that's like 3 separate things, but
Right.
you're saying this can view it all, right?
So there are leak alarms. As you see these red X's, there's one controller that we have that's offline. It's currently being worked on. But that's a good way to see it. If you guys ever see these red X's on the system, it means that device is down. And if you go to your alarm panel, I can actually pretty sure I can tell you ATS right here. Device offline, ATS 1. So
Is that supposed to be?
No, it's going to be fixed.
Okay.
There's a problem with that controller.
And that's view only too, right?
Yep, everything's video only on this. UPS, data center, MRN, UPS statuses, same thing, monitor only. Pretty much if anything ever pops, it goes here. So, oh, and then your alarm panel, sorry. You have your alarm viewer. Anything in red is a current alarm. Anything that is green means it was an alarm and recently reset itself, and that it's just looking for you to say, for this example, CVB24-16 is pretty much saying, all right, it's a low temp alarm. It was a low temp alarm at, looks like that just reset, but it triggered at 12:11. Wow, right after noon, and then it cleared itself a little bit after that at 12:29. So you come up here. If it, like I said, if it's green, it's good to go. Hit check. It's going to go away out of your alarm console. These yellow ones are ones that are an alarm, but someone has come in and said, okay, I see that you're an alarm, good to go, so on and so forth.
Where do you do that?
To acknowledge it,
Yeah.
you can come up here,
Mhm.
and you just hit acknowledge, and you see it just went down here.
But it didn't clear because it's still.
Because it's still currently an alarm.
And is there, what all these means, like CV1, 4, is there like some kind of reasoning for what they are, or how are they
How they're
designated? Yeah.
So CV is constant volume. All VAVs in your building in the new tower are constant volume. There's no high, there's no low. They're one flow set point and they hold it. The first number is the floor. The second number, it's a thing that we still got to go through and fix. It's supposed to be the air handler that is served by. So obviously everything's not served by air handler 4 in your building. Wouldn't be very efficient. So eventually these will all be different numbers.
Okay.
Like for all the 5th floor, it'll say 5-3- and then the last number is just the box identification number. There's nothing fancy about it. Nothing special.
Let me
going on
ask you
there.
one question right here. After you got the shop right there, did you feel
So,
something?
Any questions about the quick system? I guess. Pretty
No,
straightforward.
you
You
feel
guys,
something?
you guys have done plenty of guessing around.
No, actually, the stuff you just showed me, I haven't. So it's
Like all the stuff in the
actually
miscellaneous. Yeah. Yeah.
So I've just been messing with that stuff, you know, with the temp in the rooms.
This stuff is like gonna be happening maybe when you guys do checks. Other than that, I mean, it's we just made this. This is just non-critical HVAC system stuff. Obviously, this stuff is critical, but it's just not gonna fit under it. So we'll start from the top down. We're gonna start with air handlers. AHU 1, 2, and 4 all work the same. 3 is a little bit different. It's not that big of a difference, but it's a little bit different. But we'll sit here and look at 1. 1 is pretty straightforward. Everyone has a pre-filter alarm, a final filter alarm for your filters. So if those ever stay dirty, all it is a pressure switch across the filter. So if it sees a lot of pressure from behind the filter, it's going to say okay.
Okay, so it's not like a timer, it's an actual sensor.
It's a mechanical switch. Yeah. You have a chill water valve and hot water valve for all 4 air handlers. So down here, you have a command, a fault. A fault is a point that we have wired directly to the VFD. If that's in fault, that means the VFD is physically having a problem, and that you guys probably need to go check that to see what's going on. You have a status running, which is also picked up from the VFD, and then a per spent speed is that's what we send the VFD to run based on our loop for our supplier static pressure.
So you say if you have the issue, you can just go up and check and see what the VFD is actually putting out.
Yep. Only if this fault is.
That fault is which color? Which one?
Right here.
Right there. Oh, okay. All right, gotcha.
So if that's blinking red,
Okay.
it means that the VFD
Gotcha.
probably is in
Okay.
overcurrent, for
I see
example,
what
or
you're
stuff like that.
saying. Oh, okay.
There's 2 more alarms that come with this unit, with 1, 2, and 4. There's a supplier fan failure alarm. What that means is we've commanded it to start, but the VFD never returned status. And that usually means someone either went up and hit it off, or the disconnect is off to it, or you guys are doing maintenance on it. You know, that could be one of it too. The second or the third alarm rather is the supplier fan and hand alarm, and what that is if our command is off and we have status. That means someone went up there, put that VFD into hand, and is running at a static speed.
I see.
Not that usually these air handlers are ever off on you guys be a 24/7 facility anyways. Every single one has a supplier flow sensor reading, so that's just a good way to see if you're putting out the right flow. There is a high static switch on the discharge side of the fan. These are kind of weird. So inside the fan, you'll have to manually we'll go take a look at it, but you're going to have to manually hit the switch because there's a switch on the front plate of it, as well as software reset it. Pretty much all it does is this will blink. It'll just say, hey, this fan tripped out on a high static.
What does high static mean?
For example, let's say all the fire dampers shut off, and for some reason the air handler didn't shut off. So everything on the discharge side of it, from the 3rd, 4th, and 6th floor are shut.
It'll be overpressurized.
It overpressurizes the plenum, and that's just going to make it so that you're not blowing up any duct.
Now, say for instance, you got a lot of air that creates a lot of static pressure. Sometimes you get that with moisture, rain, or whatever. Will it have any effect on any equipment in our operation as far as the static
Not really.
No.
It
Okay.
should be, by the time it's downstream, it's going to be tempered,
I see.
and it should be pretty much okay. So then you also have the supplier temp, and then underneath your supplier temp is your set point. All of them are set for 55 degrees. You guys can obviously change that to whatever you want.
But those we can change.
These you can change. Anything that's in bold
Mhm.
is changeable. So you can
Okay.
see the speed set point, command, set point for the static pressure, and then the set point for the supplier temp, as well as your two valves.
Now, anything within your parameter of your circle there, you can go in there and change it?
No, bold. The bold.
The bold.
print.
Just the bulb itself.
These ones you can't change. These are monitor only. Those are just.
Fixed. Okay, what about, okay, we can change it.
So if you click it, you can change the hot water valve, or the chilled water valve rather, and make these
Okay.
changes to
Yeah,
like.
you notice how the print is a little darker, and this one's a little bit.
It's a little thicker.
Gotcha.
Thinner.
Gotcha, okay.
Now, if you guys ever see a hand like this next to something,
Mhm.
that means someone else has come in and overrode it.
Oh, okay.
So that's what that hand means, and it will stay at this value until you clear it. The best practice to do to clear this is you actually hover over the little red hand, and you get this little prompt that says click the red hand to fully relinquish force value.
Okay.
Click it, you're going to get this little prompt, you're going to hit yes, should clear, and then it's going to go back to its controlling value.
I got you.
Same with the speed. You always want to hit force if you want to override it.
Gotcha.
Always hit force. So you hit force, change it. I'm obviously not going to do this one. And then you go through the same motions.
We press OK, right?
You press OK, yep. For command, since it's only a 2-position point, so they're going to be on or off, you're going to hit forced. You're going to choose what option you want that to be in. Then you hit OK, and then that little red hand will show up.
What
next to it.
options do you have in that? The setting icon, that gear icon.
This stuff is just stuff that,
There's nothing.
yeah. I mean, you can also force it from here, but
Yeah.
this is just backup stuff. It's going to be all blocked out for you anyways. As obviously your supplier temp and your supplier temp set point is going to make your chilled water and hot water valve go up and down. Pretty basic controls, nothing crazy about that stuff. Your supplier static pressure, same thing. Your fan's going to ramp up to make sure to maintain it, or ramp down if it's too high. Nothing special about
I
that.
got you.
Your air handlers are actually pretty straightforward. They're all outside air. No dampers, no nothing. They're actually going to be pretty sweet for you guys in maintenance. And like I said, air handler 1, 2, am I loading the information, and 4 are all exactly the same. This one's got the outside air sensor for the whole building on it, so we just display it on this one as well. But that temperature is also up here in the right-hand corner.
And that's outside air?
Outside air. So we use this for, there might be a change order going through to control the supply temperature for the hot water system off of a reset. So this temperature is going to control it. I can't think of anything else, to be honest. I think that's it. It's just good reference anyways, so because since these are 100% outside air, you know that, alright, this is the air that these coils are tempering. Air handler 3 is a little bit different. It's just got an extra set of VFDs as well as a humidifier valve.
Oh, okay.
This one only serves the 5th floor. It only serves one floor, because that's the room. That's the floor with the ORs.
Gotcha.
No.
This can actually be released.
Are they? When do these alarm? Like, are they set to alarm at certain points?
Yeah, sorry. Actually, all air handlers will have an alarm on the supplier temp as well as the static pressure. Your filters, like we talked about, are also alarms.
Right.
They'll push to your alarms panel.
I'm just curious what the settings are for those. Or can we change it and set the settings?
They are hard-coded, as per request for the sequence of operations, unfortunately. But it is.
So we can't change it.
No, you can't change it.
Okay.
It's if the supplier temperature goes 5 degrees above or below
The set one?
for the set point for 5 minutes. So it's got to go to like 60 degrees for 5 minutes until it trips, and then it's got to go below 50 degrees for 5 minutes before it trips a low temperature. Same thing with your static pressure. This is on the opposite end. It's 25% above and 25% below. It gets really confusing with the statics, just because that's how they wanted it. So if it goes 25% above the static for 5 minutes, it's going to go red. If it goes 25% below the set point for 5 minutes, it's going to go yellow. On this unit, because this is the only unit that has it, the supplier humidity is going to do the same thing. I believe that one is actually 15% above and 15% below, or maybe 10%. I don't have the thing right in front of me. But like I said, this will all be spelled out to you guys in your sequence of operations through our O&Ms.
So the ORs be pretty well balanced throughout all the operating rooms, or that whole area, I should say.
Yeah.
Okay.
Yeah. So what this does actually, so this humidifier valve works off of the humidifier. OR4 will be added in here once it's complete. But OR1, 2, and 3, what it does is it takes all 3 humidities and makes an average, and then it takes that average and then it tries to control to a 60% average set point. Sorry, 40%, not 60.
So we're able to change that, huh?
These bold ones you're allowed to change.
So we can go right there at that point and change
What's the
that out.
difference between the global and the...
The global humidity set points for all 3. The dehumidifier set point is what this controls here. So in this unit alone, if any of these room humidities go above 60% relative humidity, the dehumidifier control is going to turn on, and what's going to happen is it's going to enable the dehumidifier sequence. And what's going to do is, all it does is it drops, and you can edit it right here. It drops your supply air temp by 4 degrees.
So what is your good setting just for OR itself between the high and low? Is a good setting for that?
So right now they're set for the low end of 40%. Well, they're going to control for 40% rather. And if they get too high, 60%, it'll start dehumidification process.
Oh, okay.
All it does is it requires one room to go above 60,
Nice.
because that's more of a safety precaution than anything.
Okay.
So, this will be clickable. I don't know why they're not. That one is. But yeah, it'll pop up the same thing. If you guys ever forget, there's this little thing right here, dehumid set point. You have to shorthand everything. It's one of the so many characters in the back end.
And I see there's 2 fans, supply air fans.
Yes, so there's 2 fans. As you saw on air handler 1, 2, and 4, you see how you have the failure alarms? Unfortunately, because we don't have a switch, there's a switch on the front of this. I don't know if you guys have seen it. We'll obviously go take a look. But there's a switch directly on the front of the cabinet for air handler 3 that lets you select VFD1 off or VFD2.
Okay, I think I seen that.
So what that does is allows you to select manually what VFD1 earned. That's in case if, say, VFD1 craps the bed, you guys have an immediate backup.
Switch over, gotcha.
Does that transfer automatically?
No, it won't. It's gonna be a manual thing that you guys. So if we have a fault, just like the other ones, so that's an actual relay within the VFD that says, all right, if there's anything that ever goes wrong with this VFD that causes it not to run, it triggers this relay, and we send an alarm out to you guys in your alarm console. Potentially, you guys might be getting a pop up for this stuff too. That just pretty much says, hey, I'm an alarm. You guys will have to run up there, switch it to VFD2 until you can figure out what happened to VFD1. The reason why we don't have the failure and the in-hand alarms is because we don't know the status of that switch.
Oh, okay.
So we can't generate it. You guys just be getting alarms all day off this unit if we had that in there. Because right now, VFD2, the manufacturer only allowed us 1 command for both VFDs, so that's where it kind of gets hazy. There's the speed for the both of them are going to be the same because there's only ever going to be 1 running, so we just feed the same speed to both. It's going to control the static.
Maybe, so what I meant was, does it alternate on its own, like automatically like a boiler would? Or we would manually cycle it, for 1 and 2, just to have enough equal runtime?
For the runtime, you guys will have to manually
Okay.
flip it, unfortunately.
Is there a counter?
No, there's no counter. It was not required. If you guys want it in the future,
Yeah.
I mean, even
So we just kind of Like, okay, like every year we do it in
Maybe every month,
January.
like the third of every month,
Yeah,
switch it or
like that,
something.
yeah.
I mean, that's a good thing to do anyways, just so you know both VFDs are always running, or working rather.
Right.
Also, there's one other thing. The supplier flow switch is only in Air Handler 3. If this isn't made, your humidifier won't run.
Oh, okay.
So that way you're not just making it rain
So
inside
you
your...
can actually go there and actually start it from this set point. What's the way of setting that if you have to turn it on or get it running? Will it start of itself?
It'll start
Auto?
itself.
Okay.
It's just all that switches is a mechanical switch within inside the unit
Okay.
that just compares pressure and makes sure that there's actually a flow going through this unit. All it is a safety for this valve. As soon as this switch goes to 0, for some reason there's not enough flow going through, your VFD fails, it's going to kick the switch off and then it's going to kick your humidifier valve closed.
And can we control it here? Can we turn it off like right now?
The switch?
Yeah.
It's a monitoring point,
Okay.
so it's not going to let you.
Okay.
It's just kind of how it works.
Just
Also,
curious.
you can override your humidifier valve though if you guys are curious. Just be careful. If you override any of these points, so like the speed, the command, or your valves, I think that's pretty much it for this. Any of these that are an output, if you override it, you're cutting out normal operation sequence. So as soon as you guys override it here, we have no more control over it. It's going to be stuck. If I overrode this to 47%, and say this got too low and the hot water valve started to open up, my system doesn't know that this is overridden.
I see.
Your system, rather.
They won't get any alarms or anything or any.
We are building a page that, on David's request, is going to go up here. There's going to be another little tab. It's probably going to be between alarms and miscellaneous, or it might be after. But it's going to, all it is going to be a list of everything that is overridden in your system. So that way you
Yeah,
guys...
that's actually what we were having a log for, because when you manually did
It's
it,
up there.
yeah. So then we wrote it down just in case we change shifts or something.
Right. And that's what that alarm is going to do. So that way if someone comes in and clicks, usually...
And forgets to put it back.
Right. And maybe they forgot what VAV it is. You can at least click on
Right,
this.
and
and you can
they
see.
forgot what they changed.
You guys got a lot of VAVs, so I can't blame you. Until you guys at least break into the system. Any questions with the air handlers? They're pretty straightforward.
Yeah, it's pretty good. Basically, I just want, some the information is good. I just want to know if something has to happen, you know what to look for, you know what to expect out of it.
Oh yeah, of course.
If there's a signal failure or whatever, that you can manually go up and see exactly what's happening. Or you physically have to go there.
Oh, of course.
And
Anytime there's an alarm, you guys should always verify.
Yeah, check it, yeah.
Of course.
Definitely.
Yeah.
And I mean, I'm assuming obviously there should be like some knife switches or big breakers that controls everything if we ever needed to shut it off in an emergency.
The one system that I've noticed that doesn't have a disconnect is the boilers. That's the only thing. All the rest of them, all the VFDs, you can hit the red button on and there's a big black switch you can just swing closed, or open rather.
Mm-hmm.
Yeah, there should be everything. Everything's got a disconnect
Except
or at
the
least an off
boilers?
switch. Except the boilers.
Steam or
Hot water.
hot water?
Not really sure why. The boiler guy I noticed that 3 weeks ago.
That's interesting. Is there, would there be a good reason why that is?
I think it's against code. I actually think it's against code to not have that. I think you're required if you have a piece of equipment. You
Right, you have to be able to turn it off.
Yeah. So I don't know what
Let
that's
me
about.
make a note. Is that hot water?
All the 3 boilers. When we go up there,
Yeah,
if we
yeah.
have time today, I'll show you. So luckily your air handlers are pretty straightforward. There's nothing crazy about them. You always control to 55 degrees, or if you guys want to change it, you're more than welcome to, of course. But the default's going to be 55. Static pressure, these are balanced values, just a heads up. So as you can see, air handler 1 is set to 1.7 inches of water column, while air handler 2 is 1.5, 3 is 1.5, and 4 is, I think, also 1.5. Yeah. But these are still set from the balancer. He says this is the minimum static you need to meet all your flows and all your VAV boxes that are served by these. I also didn't know if I pointed this out, but it tells you up here what floor each air handler serves. So, that's air handlers. I guess we'll just go through all the air systems. FC1, that's in your main electrical room. Big honking fan coil unit in the ceiling, cooling only. Uses the cool water from your chiller.
You got a VFD for that as well.
It-
That's that right there.
There's a VFD, but we don't control the speed.
Oh, you don't.
It's a set speed on that VFD, and that was for energy saving purposes for you guys.
Oh, okay.
Um,
That's the one right next to the
I think it's-
main panel.
I think it's kind of
But you
high
got
up.
the one in the unit that's up in the ceiling.
Yeah,
But you got a VFD there that actually
Over the
doesn't
wall.
control that.
Yeah.
That's right there in the electrical room.
Yep.
Yeah.
yep. We pull these 3 points off that VFD.
Oh, okay.
So the command status, well, we command it on, but then we pull up a status of the VFD as well as a fault status off of that fan.
Oh, okay.
Excuse me. We have supply air temp, return air temperature, and then room temperature. Room temperature is right next to the door. There's 2 thermostats there. I believe they are labeled though, because one is a fan coil unit thermostat and the other one's actually a VFD that serves that room.
Do they work? Like, I mean, are you able to adjust the temperature through the thermostat in each?
So you see this graphic right here.
Uh-huh.
So on this graphic, you see it's just kind of like a plate with a button. That's a model of our sensor. That's an MNS1. That is no buttons, just purely a sensor. Actually, if we go down, then this button won't be there. Actually, all it is just monitoring. And MNS3 are the ones I think you guys have seen with the screens that has a little gray rectangle, and then it has the buttons up and down, a little home guy.
Right.
So it should also be represented that way in your graphics correctly. So as you see when we go to the VAVs, this will change from a blank plate to that adjustable one. So that, excuse me, this one you can adjust in the building, in the room. We overrode that to 70 because somebody was working in there and complaining. But the default of this is 80 degrees because it's a not occupied area.
Gotcha.
Actually, it is.
It is?
That's why we forced it.
Oh, really?
Yeah.
Oh, shoot.
Because we're making like a makeshift office in there.
Oh, really?
Yeah.
I mean, it's huge enough. You guys should.
Well, it's not us, but somebody.
The electricians were.
The electrician.
Yeah.
They're working in there. They're working out of there, basically.
Yeah, they were complaining a lot during the summer. So there's 2 modes you can run this air handler in. Oh, also there's a filter. Forgot to mention that. Same thing as the air handlers. That'll go red if it's an alarm. This can run in 2 modes. It can run in constant, where the fan's always running no matter what, or it can run in cool call, which I turn this off. And I think it should go off because, yeah, it might have a minimum
This is
off
Steve?
time.
Hi.
But pretty much what a cool call is when you flick it, it's going to only turn that fan on whenever there is a cooling call. So anytime that your temperature is above set point and it needs to run, that fan will turn on. It will cool down below the set point. As soon as it's
No, I do
satisfied, the
not.
fan will
Where's
turn
he
off,
right now?
and the room will stay
So you
stagnant.
have a thermostatic control fan that's there.
Yep.
Hi.
We
Where are you
keep it on
located
constant,
right now?
just because in those rooms you
Right,
pretty
yeah.
much always want it. But
Yeah.
that was an option that was asked for, so
Oh, okay.
here it is for you guys. Same thing with the air handlers. You
Okay.
can override the valve and the command on this stuff. Set point you should be able to override. And if you ever have a problem, you can just go ahead and go in and override it.
Okay.
Pretty straightforward unit.
Can you
Nothing
come to the
crazy.
shop right now? Do you know where the
It's
shop
just
is?
a cooling unit, strictly.
Yes. Okay, thank you. And then,
There's exhaust systems. I think I showed you guys this real quick earlier. This is just a quick summary of all of the exhaust fans in your building.
Okay.
Sometimes it takes a little bit to populate the data. But as you can see, these should never be red. These are your faults. If it's in fault, it means that we're commanding it on, but for some reason that fan has failed. The in-hand alarm is same thing. If we're not commanding it on, and for some reason someone comes in and puts it on in
They're
hand.
an emergency plumber for Richard. Oh, he's right there.
yes?
He's right there now.
Yo, Do you know this guy from FCC or something that's supposed to check out the third floor lighting or something?
Right. All of the fan speeds are on here. If it says
Oh, it's coming down
NA,
right
it
now.
means it's a constant volume fan. It's going to be like
Yeah,
a
he
toilet
says he
exhaust.
needs somebody to go with him.
It's always going to run at the same speed. We have no control of whether they're going up or down. Some of these are fixed values. You'll never see them change, but that's just because they were balanced that way. They're always going to stay that
Come
way.
in.
Same thing here, as well as on your other. You can override everything. You can force it, change it.
FCC?
So say we force this at this speed,
Can you please start?
little hand's going to pop up,
Sorry, man.
and then you
Hey, what's up, man?
release it from here as well.
Yeah.
Same with the commands, you can override your command and turn it on and off. You guys gotta work on it, you don't want it to turn on as soon as you flip the breaker.
You need somebody with you, right?
There's that right there.
I don't need anybody.
These are the
I thought you
tags.
said you needed to
10.
open the electrical closet.
I don't know where the 10 came from.
You guys can do that.
I think it's just kind of like a mechanical tag they came up with, because if you go to every, like this has 10,
Yeah. no,
B2, your air handlers as well. I genuinely don't know where it came from. But the second number is the where it's located.
Okay.
Eddie, can you help him out?
So like all the air handlers are the R, who are on the roof. B2 is in the basement, and then 3, and so on and so forth. AHUs, if they have this AHU tag next to it, it's like I explained earlier. If the air handler goes off, it's gonna kill that fan with it, just because of
In the building or
pressurization
the
and how
tower?
overpressurized or
You need the tower
underpressurized the space. And then if you click this,
For the third floor? No, for the
Comes up a
third
little
floor, if there's
quick
no
graphic
lock,
for
it
this.
should be unlocked.
it'll also tell you where it serves right
Yeah,
here.
if there's no lock, it should be unlocked.
Okay.
You guys aren't getting power from the new tower onto this side, right?
Straightforward, it's kind of like a mini air handler graphic. You got your fan, you got your command, you can override everything down here as well if you don't want to override it up here. But if you do say override something from down here, so I override it in this graphic, little hand should show up here in a second. It's also going to show up on your summary. So when you override a point, it should always show it across all graphics wherever that point is represented. So it's always going to say, all right, even if you overrode it here, it's still going to show you on the summary that I'm still overridden as a point. And you can release it from either location.
Hey, you know what? Let's do it tomorrow, okay? Yeah.
Yeah, these are pretty straightforward. I believe it's 18 is the only, EF18 is the only exhaust fan in the building that is controlled by static. That is on the 5th floor. It controls to 0.95 inches of water column. That's a balanced value. If you guys ever want to change that, you're obviously more than welcome to.
How would we do that?
Just change the set point.
Right, right there in the control?
Yep. And then you just go in, write a new one, and do the same thing as you normally do.
Are they labeled where they serve?
Yep, this should be the 5th floor. The 18 is like a general exhaust fan, so it doesn't really serve any one specific area. Because it serves even the ORs. It's like the corner report of the ORs.
Is there like a floor panel that it shows it? Or like a graphic?
We don't have a graphic for the exhaust fans. We just have graphics for the VAVs and kind of zone control stuff. Mech system stuff, we normally don't do stuff for that, but we do have it like all labeled in here. 4th floor, that's like a general exhaust fan as well.
Yeah, just curious, like physically, where would they be located? Yeah.
So, on this one, it says located on the 2nd floor, but serving the 1st. So that would mean that your exhaust fan 12 is on the 2nd floor, serving the 1st. Is that what you're looking for?
Kind of. But does it, like, where is it positioned, or like, what ceiling tower will we go up to, or?
Oh yeah, we don't have that
Yeah.
information on the graphics. That might be something that you might look at the mechanicals for.
Okay.
So on the EF number, the second number is, like say you had 12, EF 12, and it's on the 2nd floor.
Does it represent
serving the 1st floor? Is that right? Is that, I heard you say that.
Oh well, yeah, he's reading down here.
Actually, yeah, these are
He's
different.
reading over here.
It should be 2. Shouldn't be 4. See how it's 2 up here? Because it's located on the second. So you're right. The physical unit's located on the 2nd floor, but still serving the first. So this should actually read 10-2EF.
Oh,
Sketch. Write that down. Is it all? Of course it is. Why would it just be one?
And the description, it just says storage. So
This-
is that first floor storage?
This one is it's actual storage on. I think this is actually outside storage. It's kind of weird. It's along the outside wall in the alleyway. Gosh, I can't remember the name of the actual room. But it's
Oh, the disaster room or something like
I
that?
think
Is that
so.
the one in the back, far back?
yeah, it's at the far back corner near the parking
Okay.
lot. Which I think at the time it was just called storage.
Okay.
That can be changed though. Also, if you click the air handlers on these, it just brings up a quick little snippet for you guys. So you can just be like, alright, what's going on with that air handler? Okay, I can see that. Alright, you can just click this X, brings it off. Alright, number 2, same thing. Kind of neat little feature. There's another exhaust fan. Actually, I believe it's 18. If any of the 18 or 17. Correction. 18 serves the ORs as well. So if all of the ORs are unoccupied, 18 will turn off. But I don't know if you guys know this, but the way the ORs are set up, it has 4 exhaust points throughout the room. 18 serves 3 of the 4, and 17 serves the last one. So say it sounds kind of confusing,
Yeah.
but it's actually kind of smart. So what happens is if all of those turn off, we close off the supply boxes, and we bring that room down to a minimum. It's their way of making it still exhaust a minimum amount while it's unoccupied.
So they're all being circulating, right?
Right. And then you can just turn off an entire unit and pretty much turn off all kinds of energy wasting.
So you have a set point with all your magnet helix gauges and all that. There's that specific set point that you want to maintain, like for the ORs itself.
The ORs, we
Yeah.
don't have a static pressure.
Okay.
Those are kind of just,
So what are you looking at, your filters?
those ones are just a supply and exhaust box.
Okay.
And we just keep the exhaust box higher than the supply. It's, I'm kind of weirded out by that too, but even though, because like your isolation rooms, there's not a set point, it's all a hard-coded set point within the unit.
Oh, okay.
Now, these designations with these numbers,
Hey,
are
Ethan.
they?
Sorry, Steve.
Yeah.
Real quick, we just got a work order for 3rd floor. Third
Bedroom?
floor. Yeah, bedroom is
Yeah, I
2
already showed up.
Is
But
it
it's a
1?
general area though. That's the one I was talking about. So we can't isolate.
Do you guys
that
have a
one room.
new mechanical print for this building or not? Not yet.
So it's a whole zone. It's like a whole area.
And we
It's
also
already set at
we also
65.
get pharmacy
Right
a
now
lot
it's at 50.
on the
Alright, buddy, just leave it.
first
Thank you.
floor.
Yeah.
In here, pharmacy also
Alright,
calls quite a bit
Oh,
about
okay, no,
it.
Richard,
It is too cold or it's
What the hell's he doing?
not
Oh, let's go visit him.
cold enough.
Yeah.
And then you get one, well, it's too cold.
Right
And
when you
go
call
ahead
it, you got something
try to
outrageous,
set that
fucking his whole body
parameter.
turned red.
I'm telling you, man.
And maybe about 2 or 3 hours later, somebody called.
Well, like, it
"Oh,
just turned
okay,
hella red.
It's just a little too warm. Can we get it just a little bit colder?"
Yeah.
So I seen that with pharmacy when I was here, like weekends. I've
Yeah.
gotten that, calls through that. So that was another thing that I was kind of looking at, because everybody. But you got more than one person.
Right.
And most of the time with ladies, man, it's always an issue.
You will never, ever get it right.
Definitely.
So my question was, the exhaust fans, are they all designated the same on the actual blower or fan in the roof on the penthouse? Like, can you go back to the exhaust fans?
Absolutely.
Like that 10-4- something something, is that designated on the? I'm just curious because how do we identify that this exhaust fan is that one you know.
Well, these should all have the same matching tags on
Right.
the exhaust
Okay,
fan.
that's okay. So they do.
They do,
have
yep.
matching tags.
Also, the second one is what floor it's physically located on. So like
Mhm.
R
Mhm.
through 5 is 5.
Yeah, yeah.
So-
Okay.
So now from your VFDs, I notice you got on there you got your hertz that's coming in,
Mhm.
and you also have your second set point, which is I think is
MA.
MA
Yep, milliamps.
milliamps there, and then you have the bottom one that seems to be corresponding with the hertz.
Yep.
The top part of it we get is kind of reading it just a little bit higher, and I think there's like a MA. Not, I'm thinking M. I thought
The
it's
the
A or something like that. I'm not mistaken.
the MA is milliamps.
Milliamps,
That's
all
our
right.
our signal coming in. It
Okay.
tells you, all right, because we're on a 4 to 20 signal for these VFDs.
Gotcha.
So it'll actually tell you the raw input. Do you want to sit?
No, I'm good.
All right. I feel bad because I'm
Nah.
like, sitting. But that'll just tell you like, okay, so pretty much, let's say EF17 for example. If you walked up to that exhaust VFD, it should say 10 MA or somewhere relatively really close to it, like maybe 9.9 MA.
Right.
Because that's just saying, all right, we're at our half of it. Actually, if it's 4 to 20, it should be somewhere probably around like 11.5, somewhere 12.
Gotcha. Okay.
And that's just kind of, it just lets you know that like, all right, this is the control signal we're getting. And then it translates that to a 0 to 60%, 60 hertz.
Gotcha.
But we actually see it as a percentage.
I see what you're saying.
So is there a way here to manually control the VFDs?
Yeah, absolutely. You can just go in and click these percentages.
And then
So you
higher
want-
number is what?
So 100 would be 60 hertz.
Okay.
It's kind of
That's
weird like that.
full speed, right?
That's full speed. 50 would be 30 hertz.
Uh-huh.
And then I believe anything under 25% you can't really do anything with because that's when you're hitting your 15 hertz. And then that's minimum for all VFDs.
Okay. Do they show where they're physically located?
The VFDs
Mhm.
should be these numbers.
Those are the VFD numbers.
Actually, some of them are.
Yeah.
I believe they're all according to these numbers correctly.
Because I noticed air handle 1 that's up there
Yeah.
has a much higher voltage rate
Yep.
compared to the other.
I think that's the biggest
three.
one you guys
I
got.
think that's about 100. It's about almost 100 and something.
Yep.
As far as the hertz is concerned.
Yep.
And then I noticed it has, as it comes down, it may hit around the bottom portion is about 80, something like that. You know, you have a like.
I think all of your fans are 120 hertz.
Okay.
I want to say that.
All
All of them.
Okay.
I'm sorry. All of your air handlers.
Oh, okay.
Fans.
Air handler. Gotcha.
All your exhaust fans should be 60 hertz. I
Okay.
think that's just because
Is
they're.
there a reason why these are NAs?
So these are NAs because they don't have a fan speed. They're just
Oh.
we just command it on and that's it.
It's just on and off?
There's no VFD for
Right,
these.
okay.
It's just like a contactor. We pick up a status through a CT for those.
So your pre-filter, your alpha filter, they have their set points that you want them to actually be at. Could you actually pull that up on there as well?
So like final filters, the HEPA filters in this unit, because that's I think AHU5. Do they all have HEPA filters? I forget.
I'm
Yeah.
pretty sure they do.
I think
Yeah,
all
on
of
the, I know you got them on the OR
Yep.
Supply Fan 3.
Mhm.
And then you got the Hot Lab, they got Helper as well as one of the labs up there. I think 25, exhaust fan 25, something like that if I'm not mistaken.
Might be it.
25, 23. I know those was Helper. So I was basically,
I think it's
was a
22.
good set point for those.
So these are actually set manually. They are a hard mechanical switch.
Okay.
If you guys ever pop off the cover of these things, and if we wanted to, we could look at one if we need to. Excuse me. I don't know why I have the hiccup so bad today. It's a little dial on the front of it,
Mhm.
and the way it works is it's a little like you have to use a flathead to adjust it,
Right.
and it'll actually show you this little arrow with the INC,
Okay.
and that arrow means you're increasing the inches required for the
I
switch
see.
to trip.
Okay.
One full rotation is 1 inch of static.
Oh, okay.
So I believe we have these set for, I want to say 2.5 inches.
Okay.
No, I want to say 2. considering these ones are pretty high already.
But you generally don't want to mess with that, right?
Yeah, generally you want to keep them. I don't know. I'm guessing you guys have your own rotation for filters, anyways. Most buildings do. You guys change it once a month or every 3 months or something like that. So yeah, that's exhaust fans. Pretty
Now,
sure.
is there any information on like the size and dimensions of the filters that we can get from your screen?
Not our screen, no.
Okay.
That's going to be all through your mechanicals.
But I thought it was one-stop shop.
Yeah, I know. I wish.
Nah. Okay. Cool.
We will be putting the. I think we're gonna put it somewhere on the top bar because that top bar is always showing on every screen.
Mm-hmm.
We're gonna put a little icon to. We're gonna give you guys a digital version of our O&Ms, so that when you click it, it's gonna pop open a PDF, and you're gonna have to look through the PDF for what you're looking for.
You guys are gonna have that, or
We're gonna-
give that to
We're
us?
gonna
or-
give it to you guys. Yeah.
Good. Good.
You're gonna have a physical copy because we require that,
Mhm.
but we're also gonna give you a software copy because nothing sucks more than having a paper here and then. Because also the nice part is once you have that PDF, you can do it like a Control F, and you can just search through the document for what you're looking for. So yeah, that's exhaust fans. Pretty simple. 18. Like I said, it's the only one that's controlled by inches, just because that's the ORs. Humidifiers, it's kind of like the small humidifier section out of Air Handler 3. You can see they all have switches. These switches, if they aren't made, so say like and all the VAV boxes on the discharge side of it are closed, and this sees no flow, it's going to go on. Oh, I'm sorry, other way around. It's going to go off. So what it's going to do is going to kill your humidifier valves. And then on each valve as well, you have these supply humidities. This is on the 5th floor, and these are on the 6th. This is ICU rooms north, ICU room south. Even though they're really close to each other, which is kind of nice for you guys. I'm going to admit, I hope you guys never have to work on these things because they are a pain in the ass to get to. They're like, I mean, where the bottom of that is like the bottom of the duct, and like the grid is right here. It's just like,
Yeah, we already. Yeah, let's not get into that.
I know. I feel so bad for you guys on a lot of these VAV boxes. Luckily, the commissioning agent, when we were going through, he was like, "Hey, like this can't be it," and they changed some boxes. But anyways, yeah, this is pretty much these are the 3 standalone humidifiers. They're gonna grab humidity from all these rooms. I don't know why these 2 don't. It's gonna have a set point like this one, but it's gonna be the same idea as Air Handler 3 with the ORs, where this one's gonna be an average of all these rooms, and then it's going to be one set point. And it's always going to try to control to this one set point. And of course, you guys can obviously change it. Okay. Actually, I'm going to write down. What was that room called again on the 3rd floor?
Which one?
The one that's getting warm. Is it med room?
Yeah.
That was a mid.
Medication. Yeah.
I'm just going to write this down for me to look at tomorrow. Cool. Alright. Yeah, so it works just like the air handler. You can obviously control, oops, that's not the valve. The valve if you wanted to, you force it, but once again, if this switch goes off and you have this overridden to 50%, this will stay at 50%. So you guys gotta be really careful with how you override like humidifier valves. Humidifier valves will end a lot worse.
Like the whole thing will be just soaked in.
You'll be coming home to a pile of mush of
Yeah.
ceiling tiles on the floor. But yeah, like I said, this one's gonna be an average of all these rooms for the set point. I just gotta expose it. That was my bad. Same for this one. It's just gonna be a set point, and then you'll obviously control as needed. Pretty straightforward stuff for the humidifiers. RF12 is not a thing. You know what I can do? I'll show you the graphic for that other unit. Come on. AC1. That's the name of it. There it is. Very simple. I just gotta add it to the sidebar.
And that's the one for the elevator?
That's for the elevator room.
Okay.
This
That's
is,
that one that's
all you guys
replicable.
do for that is send it to set point. That's it. That's the only thing you can do with that unit. That's the only thing we're allowed to do with it. We don't get anything else other than a status, a cooling demand, and the room temp is actually our room temp that we feed it.
Oh.
So if you click this, it's not going to do anything. But you can still set the set point if you wanted to.
I got you.
Are you going to make a fool out of me? Alright. That's a quick look at that. That's going to be under air systems. It'll probably go right here.
Okay.
Um,
Are you gonna label it like elevator?
I could call it elevator. I might call it, for
yeah.
the roof tag, it's
Yeah.
going to be 10R AC1.
But in the description.
Yeah, that's
box,
the elevator room.
Okay.
For sure.
Cool.
Room pressures. I'm sure you guys have dealt with this a lot. These are the room numbers.
Now, we've been in one room in particular, I think in pharmacy.
I think
chem hood, yeah, I think it was probably the chemical hood, I think. It was, oh wait.
it was any room that was causing issues.
Any room? Yeah, so.
So we just replaced one recently,
Okay,
and I think it was we made it a higher range.
I see it.
Now the thing I see with pharmacy is that they have the lobby, which is an open area, and then they have their room that they're in, which is
All the
enclosed,
machinery.
yeah,
And
but yet it's got the open foyer
You want this right here, right?
lobby, yeah, to the lobby out there. So you got that quarter, and it's open to that.
because all the ladies sit right
Yeah,
here.
and everybody's there, so you got all those temperatures, you got those temperatures kind of sometimes like collide with each other. So somebody wanted cold here, but yet that perimeter is totally different, so I see what's happening there.
Most of my
So that basically, this one controls that whole area, right?
controls this area right here. This one controls this back area. This one controls this the corridor area right here. My favorite story. I'm from New Hampshire, so it gets real cold there.
I'm from Chicago.
Okay, so you're familiar with snow.
Yeah.
So we had a post office we were doing, and same setup. We had the ladies in the line. Lady at the end had the thermostat. She's the one who brought in the space heater because she was cold in the winter. Well, what happened was we sat there and she cranked on that heat, and it just full opened the air handler to cool it. And all the rest of the ladies are sitting there freezing, and you see that one lady just typing away, having a dime of her life. One of my favorite stories. It ended up freezing the coil and split the coil open like Swiss cheese.
Yeah, they will bust those coils. I've seen that.
I don't miss that about San Francisco.
Yeah.
No cooling issues here.
Yeah, I've seen it crack coils, man.
Oh,
Crack steam lines. That was
Like, did you ever work at
exposed.
Seton? Daly City?
no.
I heard they don't even have air conditioning.
Really?
Yeah.
No shit.
Oh yeah.
Yeah.
Well, we have we actually have some customers in San Francisco that don't even have air
Yeah.
conditioning. They
Yeah.
just rely on the outside
Yeah.
air.
It just open windows. It was
Yeah.
hot.
In New Hampshire, and maybe even Chicago has this too. There's a lot of places that don't do cooling, and then like if they want cooling in the winter, they just open up their outside air temperature.
Yeah, you know what the city of Chicago did is build chiller houses. So that way they, say for instance, like downtown areas that basically they want to buy chill cooling, they piped all that into those buildings. So they took old stores and they put what they call the cool houses, so they got chillers in them. That they sell all that chilled water
shit.
to all the buildings
kinda smart.
downtown.
Are we pretty much done?
No,
No? I was.
we're still cranking.
Yeah,
Oh, okay.
yeah, that's a lot of stuff.
Do you want to be done?
I thought we covered everything.
Oh no. Well, I'm gonna go through the wet systems real quick, and then we'll go take a look at stuff in the field.
Sure.
I mean, this is going quick. There's only two of you guys.
Yeah,
I thought
yeah.
there was gonna be a lot more. Just so you guys know, there's gonna be more trainings. So
Okay.
play around the system until next training. Write down any questions you guys have,
Gotcha.
Yeah, yeah.
and then ask me at the next training because
Yeah,
that's the
next
best way
time
to
you
do
come
it.
back, I'm pretty sure we're gonna run across somebody.
I'm
else
sure that pad of
problem
paper is gonna be full of shit.
that somebody needs something done.
Oh, of course. So let's go. We'll do some quick run through of the chilled water system, the hot water system. Even though we kind of went through them really quick already. Chilled water system, really straightforward. We just send a temperature. Here's your chilled water supply temp right down here. We send that to the train chillers over the integration. and it controls down to it. As you can see, this is our sensor. These are our sensors as well, actually. So this sensor should always match something relatively close to that, as well as your active chiller should be actively discharging something close to 44 degrees as well. Hey, see, how's this percent close? I got that one right. I gotta change it to make it read that one on the MRI page.
Yeah.
But so these three, as you can see, are running right now. This is a point we're trying to make with the mechanical engineer, but it controls this set point here. As you can see, with all three VFDs at 95%, we're barely making our DP. My argument is this is in the wrong location. It needs to be in a better location. But I was told to leave it in auto. So right now you're going to see all three of these running, and they're going to run all at the same speed. The way that these stage down is the lag pumps need to go below 60%. Once it goes below 60%, it'll switch full back onto the lead. Once the lead goes above 95%, then it'll start kicking on lags. That's how like the pressurization works. It's always going to control to that. These three are going to control to this. You can also see these DPs right here across your chillers. And then you see this chiller DP set point. That's where this bypass comes into play. This bypass is always going to try to maintain 6 PSI minimum, actually maximum, through all three chillers, because the Train told us that is the optimal flow you want to have through these chillers. Is 6 PSI to have the best energy pickup, or loss in this case, in a weird situation. So this immediately correlates with this, as well as these three sensors. And these three sensors, it caters to the lowest value. So let's say this one was reading 4 dP, and this one was reading 6. It's going to take the 4 dP, and it's going to try to control that one. But if for some reason these switch, it's going to start controlling off of this one, just because it's going to try to maintain the minimum flow through the lowest PSI. Oh, jeez. Excuse me.
What are these guys?
These are secondary pumps for your data center and your MRI, and they control to this DP.
So the MRI has its own pump.
They
Chill water pump that actually supplies the chill water
as well.
to it.
So if you click on here, they have their own BPs down here.
Oh.
So on your chill water system, total, you have 7 pumps.
Oh, okay.
Kind of crazy. Yeah. Because you got these two, then you got the 2 secondaries, and you have your 3 primaries.
Gotcha.
As you see over here, you can just click on MRI, it'll bring you to MRI graphic, or you can go over here. So you can see these valves too. We have statuses as well as the command for them. We do have a fault. If any of the valves, well, we try to open them, don't make status after, I believe, 5 minutes, the valve will fault and it'll roll over to the next chiller. Because at that point, it thinks, my valve's died, it's not working, it's staying closed. I need to not use this chiller because I definitely don't have flow, so it'll roll over to the next chiller. So for chiller 1, let's say chiller 1's valve failed, it'll roll to chiller 2, and then if chiller 2's fails, it'll roll to 3. It'll always be sequential 1, 2, 3. So we also have the lead chiller selection set so that it'll bump up 1 chiller. So it'll go 1, 2, 3, 1, 2, 3, and then 1, 2, 3. And right now we have it set for the beginning of the month. And we're going to be making a nice chiller selection, lead selection page for you guys, where you can change it to be a certain day of the month, if you want to do it weekly, if you want to do it monthly, or if you want to do it daily.
What is this at right now?
Right now it's monthly. That's kind of the standard that people, I don't know what you guys usually do. From the sounds of that other system barely works. Also, the same thing goes for this fault right here. That's the point that we pick up from the chiller. If this fault ever goes into alarm, we immediately roll to the next chiller. Regardless of the valve or anything, it just rolls to the next chiller.
Gotcha. It's almost sort of like the boilers, whereas that you got your lead, lag boilers, so as one can't maintain, the other one will come in and pick up. And it just keeps picking up all of them until you pick up all 4 of them.
We have that too.
Bring it.
So these right here have their percentage usage, which is the tonnage. We translate the percentage in our program, which you'll see in the staging page here. So it'll roll on to chiller 2 if your chilled water supply temp is above 50 degrees, which it's not, so 45, so we're good. Also, if your system tonnage is above 110, it's at 130, but because we're not low, it's not going to make it. As well as it's at these 2 states for 15 minutes, and then it'll roll on the second chiller. You can see your tonnage up here on the right-hand side. On the main page, it's up here. Once the data loads in. It's the one thing right now. When you click on something, give it like a minute, or not a minute, that's way a long time. Give it like a few seconds, and if you see like a room temp reading 18 degrees.
Yeah, I've noticed that already.
Yeah.
You need to give a couple of seconds sometimes.
Sometimes, the way our system works is it keeps all points, to avoid over usage of all of our controllers and the network. What it does is it keeps all the points in the graphics dormant until you guys click on it, and then when you click on it, it'll populate the page. Anywho, I think that's pretty much it for the chillers. They're pretty straightforward. 3 chillers. These things run great. In the winter, you guys will only be running one for sure. The secondaries are the same way. If they go above 95% speed, what they're going to do is they're going to roll on the second one. If they drop below 60%, it'll roll off the lag pump, and it'll go back to its primary.
Can you explain that bypass again?
Sure.
What was?
So this
why is that
bypass,
closed, or what's it open?
the bypass.
Yeah. Go ahead.
You just want to know the sequence of it?
Yeah. No. What is it for? What is it?
So-
When does it open? When does it close?
This bypass should be always closed unless there isn't enough DP to our chillers, through our chillers. So if it's not going to meet our set point of 6 PSI, so if these start dropping, this is going to start going down in number. Yeah, that sounds kind of weird, but as this drops down, it's going to allow it to bypass more water to put more flow through the chillers. And that way we can have a minimum flow through the chillers, and we can pick up the most energy
So
out.
when you open that bypass up, that way you got everything going to try to get your cooling
You're increasing
down.
flow.
You're right.
Increasing flow back to the chiller.
Right,
You're
right.
decreasing flow to the field, but you're also picking up cooler water, so
Yeah.
it'll make up for it.
Because I know we used to do that a lot of times in some places. I remember we had chillers, but then we would piggyback everything to try to make up the difference.
Yep.
So we had bypasses that we would
Yep.
open to bring all that chilled water around to another object, chiller, to really help move,
Right.
move it out.
Yep. Yeah, so that in this system, that's all that does is maintain that DP set point through the chillers.
This is Steve. Yes.
Any other questions about this?
No, that's good about the bypass.
Yeah.
Yeah, I didn't, it rang the bell. I didn't think about it until he brought it up again. You mentioned it.
It's not really self-explanatory
Okay.
because it's
Which room?
most of the time you don't need it.
Yeah, you don't. Yeah, it's most of the time I know the most
Sub-stereo
bypasses
too?
ever used is
So
when there
you're
was an
inside
emergency issue
sub-stereo?
there, and it was bought. It came into play.
I have a feeling I'm about to get a
Emergency.
Yeah. Okay. So where's the machine located? Okay. Okay. Thank you. Yes.
Yeah.
Is this a stairs machine, sub-stereo 2? He was trying to run some diagnostic experience. You know what
I don't, call me on it.
Another thing is you guys will come up with your wants and needs, and we'll work out the kinks. There's still some kinks in the system,
Yeah,
and there's some stuff that you guys, each customer is different, and you guys definitely want different stuff compared to others. So we're gonna be meeting those needs.
Okay.
Another thing I forgot to mention is on each floor plan on the right-hand side, they have all the AHU that serves that floor. It'll have its status, supplier temperature, as well as its supplier pressure. Usually if you're having a problem, you want to look there first. Like if, say, the majority of your rooms are warm, Want to check your supply air temp, because your supply air temp's high.
Okay.
Maybe your
Then you
nose.
can start bringing that down.
Right.
Yeah.
So what you would do is, so,
This is
this
the-
third floor,
Hey, I got a call from OR. They said their stairs machine and substation.
you would see this, and if for some reason your hot water valve is open and you're above temperature, you would come here to adjust it.
And you can adjust your percentage on your hot water valve there.
You could.
What's the high, what's the best way of dealing with
The
it?
best way to deal with anything that's too hot or too warm is to immediately adjust the set point. So say you're too warm, and you're like, okay, I'm not really sure why you come here, and you would just probably drop this.
Oh yeah, that was an issue with the rooms. Are those working now?
Yep, we're good. We'll go over that in a
Okay.
sec. Yeah, I know that was a huge issue for you guys, and I totally understand. So if actually we'll test it on the BAV, but you'll change the set point, let the system try to bring down the air on its own. Any questions about the chiller?
Yeah.
Pretty straightforward stuff. All it is pressure, temp control. Hot water system. Boiler, like I said, we can't control the staging of the boilers. Everything about these boilers is controlled locally. All we do is we send it a set point. Well, eventually we'll send it a set point, and we turn it on. That's it. We actually turn on the whole system. We just have 1 point on boiler 1, and then that stages down to all 3 boilers. It's like a max. I don't know if you guys dealt with the situation. It's like a master-slave situation. Boiler 1's your master boiler. If that ever goes down, boiler 2 and 3 go to local control, and they control on their own. But eventually, your system set point will be here, and it'll control your hot water system temp here. It should be 160. It's 180 right now because of the issues I mentioned earlier that we're working with the manufacturer to fix. You have flow statuses in all your boilers. Also, you have these pumps we don't control. These are all monitoring points we pick up. Jesus, cannot stop hiccuping.
So normally it's, if boiler 1 fell, the other 2 you will have to go into, would you have to manually set those?
Those should automatically switch over.
Automatically switch over, right.
So the way that AirCo system works is that if the lead boiler ever pops off on a fault, it'll roll to, so if it's 1, 2, and then 3.
Gotcha.
As far as I know, if you come up here to the HLI detail page,
What is that? HLI?
it's just the integration we get from the boiler. Like they have a little, in our cabinet, they have a little node that we pick up points off of. And this comes directly from AirCo's boilers. They tell us this information. We have no control over these points. So kind of the nice part about that. This will tell you obviously your firing rate, your flame strengths, if it's in fault, inlet, outlet temperatures, and then run times. And like I mentioned before, I'm not sure, I don't know if that guy ever went into detail with it with the boiler guy, but I know these definitely stage on runtime. I just don't know at what time does it switch. Does it hit 4,000 and then turn to boiler 1, and does that run for 1,000 hours, then go to 2 and then 3?
Yeah, I notice normally when I do a surface blowdown in the morning, I do 1 first, and it would drop out, then 2 would kick in.
Yep.
It would drop out, and then when I go to surface blow, 3 would kick in, and then 1 would come back and start. But this morning I noticed I had 2 and 3 went to flame failure. And they,
Really?
for some reason, and they were they were blinking, saying it was a failure. Although I had just blown them down, so I had to go back and reset those 2.
Huh. That's weird.
Yeah, that was a little strange for
That's
that
not
to
good.
happen, because normally once you hit the the quick opening, then you hit the slow opening valve, and then you go back and close them down. Automatically, once you get up to your water level and you trip the switch there, you should automatically come right back online.
Right.
So it shouldn't have been a failure there. It should have been an automatic restart.
That's weird. I wonder why it did that. I wonder if it just got caught up on itself or something.
Yeah, could have been.
Also, you can see, I don't think I showed you guys my chiller period. We forgot to do this. You do have a GPM, gallons per minute, on the chiller. That's just a monitoring point. Nothing controls it. It's just for you guys to see. There's one for the chiller as well. It's a little bit lower. Same thing, under point, nothing else. These secondary pumps here, SHWPs, they control to this point. This loop end is actually in B2. That sensor's down in the basement. So this is just kind of showing it right where it's at the HUs, the CUBs, and then the loop end. And that's where it's located. And then you got your returns, and they come back. Any questions about that? Pretty straightforward stuff. Steam system's pretty straightforward except for the staging. Like I said, we try to maintain 75 PSI. We're supposed to maintain it with 1, but for some reason we need to have 4 on. That's a manufacturer thing. All we control is the command on these. We control nothing else. We get a fault point off of them that if these things ever fault, it'll close contact and it'll say, hey, I'm an alarm, and I'll go, okay. It'll go red for you guys. So the way the sequence of operation works, you go to the HLI detail page. The detail page is always just extra information for you guys.
How come there's only 2, 3, and 4?
So stage 2, this is per the manufacturer how they want it. So you're always going to have stage 1 on. Stage 1's always going to be on for these steam boilers. So whatever your lead boiler is, that's your stage 1. Stage 2 will be whatever the next sequential boiler is. And then the set point for that is it needs to... Sorry. So, let me get this right before I go too far. 75, okay. So if the main system drops too far below 65 PSI, it's going to kick on. But it'll have to run for 30 minutes before it'll allow itself to turn off. And that's what that means. The minimum on time for stage 2 is always 30 minutes, or you guys can change it, as you can see. Just so you know, if you guys want to do like, say, 1.5 minutes, 1.5 is going to be the representation for that. Unfortunately, it's not 1.3.
So once you come up to your head pressure, automatically they should start from coming offline. And once that fall below that point, I noticed this morning I was going to mention that, and then the blowdown, because they all
Program into the system, you think? Maybe just a little bit more?
What do you mean?
You know, like some of the features, like the being able to adjust the 2-degree set point.
Oh yeah, we want that done by then.
Okay, cool.
So, and all that stuff that I add from this to the next one, I'll show everybody.
Okay, sounds good.
You know, Dennis, did you know you were saying that hot water
Excuse me?
boilers don't
I
have
don't know if you're gonna let me stay, because I gotta supposed to leave it too.
They don't have disconnects.
They don't have disconnects? Did you know that?
I didn't know that. I'm sure if we.
We're gonna go up. When we go up, if you guys want to show, I'll show you.
I mean, that's kind of important.
I thought it was kind of important, that's why I want to let you guys know.
Yeah.
I know the commissioning agent flagged it, but I don't know how far it got. So
Huh.
if you guys make the noise, obviously it's better.
Okay. Thank you.
What's that?
It's a goddamn it.
Throwing people under the bus.
Yeah.
I don't know if they're gonna let me stay this long. They said, no, gee.
Right time? We ran at the right time. No?
Oh, no, I
I gotta stretch my legs.
gotta shut it down.
Okay. To right. Okay, you good?
Good?
Is this the ABS?
Actually, this one's got humidity on it. But we'll still roll with this one because the humidity on these are just, what is it, 6th floor? Yeah, they're just sampled back to the humidifier.
I mean, you can't really rule anything out.
But,
It's just assumption. I mean,
As I showed you guys before, if you ever come into an issue where something is too hot or too cold, the first thing you really want to probably address is your set points. And right now, the best way to do it is to go to here. And then this is going to be the high end of your set point. So say you want it to heat to 68, you want it to sit to 70, and that way it goes down to 68. Makes the room cooler for them, a little bit more enjoyable. And for some people, I know it sounds like you guys have quite the eclectic people that want hot and cold.
Yeah.
So that's the first thing you want to do. Let that sit for like an hour, half hour, let it roll, kind of watch it.
So the graphic shows that, it has the arrows, so
This
I'll
means it's
be able
got a,
to control it locally.
yep, so if the set point override's not in, I release this.
Yeah, I know, I'm starting to catch
It's going to go back to the local temp set point. And the local temp set point is whatever they have set for on that thing.
And their range is what?
I believe it's a high end of 80 and a low end of 55. Actually, I think it's even higher. I think it's 60.
Really?
Yeah.
So they have that much range?
Yeah, I mean, we can obviously limit that more, but I mean,
Well, I'm just surprised. I
in
mean,
the end, you guys usually take control
right,
of it, right?
exactly. I mean, you know, I don't mind. I
Yeah,
mean,
yeah.
So they can adjust it themselves and they don't bother us, you know?
So you do is you set it from the front end, and then you let them play with the
Yeah,
arrows.
and then don't do nothing.
Yeah, just be like, oh yeah, we changed it, and then they think it's warmer.
Right.
So yeah, I mean, it's pretty straightforward. It's your set point for your CFM. You can override this if you wanted to.
Yeah.
Obviously, it's not suggested to do so because these are obviously balanced for what they are. These boxes control really well. As you can see, it's just one CFM over. Sometimes you'll see them 10 CFM over. That's still really good as long as it's within range. Usually the rule of thumb is 10%. So as long as it's in 10% range, it's still controlling. If it's
That's what I
like
heard. He's
200 CFM, then yeah, you got a problem. Supplier damper, you can also override that. I think some of the other guys already found that out. Just do a percentage.
Sure.
Hot water valve, same thing, that's overrideable. Supplier temp, not overrideable, but that's always your first place to look to see if, you know, if your hot water valve is 100% open, but you're not getting warm.
He said
Your
he
supplier temp still 57 degrees, and there might be something wrong with your valve.
Well, that's just what I was going to mention. One of our journeymen yesterday was trying to cool a room, either cool or heat. Heat, I think it was heat. And it was like, you know, 100% on heat valve, and the supply air wasn't going warmer. So he went up there physically. No, he went up there physically, looked at it. So whoever installed it, like there's like a physical knob or handle that moves, and it was blocking it. It was obstructing.
Oh, was it like the insulation wasn't stopping it? Or?
Not the insulation. There was like another gauge or valve or connection that was physically.
Do you know what box that was?
Yeah. I mean, I can give it to you. He had to make a notch out of it and stuff.
I just want to write it, that way we can mark it down. Because we were looking through the system and we saw one. I don't know if it's the right one.
Rich should probably stay where he's at, right?
I would think so.
You got Saturday and Sunday, right?
600.
Gets off early, so you can go out and play golf.
Room
Have a good one.
All right,
6-4. Good luck on that traffic.
We might have cheesecake tomorrow, maybe.
Oh, okay.
Maybe.
Oh.
Yeah, so I'm not sure.
Oh, you gonna do it?
I'm gonna try and make a pumpkin cheesecake.
Alright.
Oh, wow.
Tonight.
I'll write room 600. I'll see what I can
Friday,
find.
for Michelle, we
Yeah,
gotta
so
have plain
with
cheesecake.
Plain
She's
cheesecake?
a woman.
But that's good, okay.
So that
Plain cheesecake.
guy was blocking
See
it.
what happens.
Gotcha.
Oh shit.
Yeah.
Alright, Bob, take it
And then he had to cut a notch out of it.
Hey, that's creative. I'll give that guy that.
Yeah, so this is the stem, I guess, right here.
Oh, it's a balancing stone.
Yeah, because you already see.
That's a nice camera. Holy shit.
There's not very many guys, there's not very many shifts.
Yep.
Only so far you can go.
Cool. Alright.
And then he's like wondering, well, I found one. I'm sure there's probably more. You know?
Right. So we're obviously going to do our own checks. What we like to do is once we kind of almost hand it over to you guys completely, so like this is still after training, we like to do a quick overview for the system, make sure sensors fail. That's unfortunate. You know, 10 sensors fail, there's nothing we can do about it. And if something does fail, you guys can let us know, and as long as it's under warranty,
Oh, okay.
check them
Yeah,
out.
if you're gonna have a firework back, they can teach you.
Make sure you get all the sensors out working
Those are
right.
good.
Anywho,
Okay.
eventually we're going to add you, like we were talking about
He's feeling a
earlier,
little bit better, he said.
going to give you guys the option to change the deadband between the heating and cool.
He's chilling out.
So these 2 points will be monitoring. They won't be bolded anymore.
Isolation room.
But they'll at least let you know what your box is going to cool to, what your box is going to heat to, and what your deadband is.
So then we just control the deadband.
So we got new security.
We don't really have to control each individual number.
Not really, no. I mean, most of the time you always want to have an option so that your box is not slamming cooling, slamming heating, and it's not going to, you know, change itself that drastically. You always want like a 2 degree
Minimum
deadband. Minimum 2 degree deadband, always to at least to try and maintain.
Sure.
Yeah, he takes real good practice.
Compare the rest of those guys, man. That's it.
ISO rooms,
You want to be there and wash the uniforms, man.
it's pretty straightforward. Let me grab another one. That's an operation.
What happened to John? Did he just gone?
Yeah, they got rid of him. He had customer complaints, you know, the way he was talking to the public and
Who?
Jonathan. The security guard?
Oh.
Yeah, there was some plates on him, so.
Yeah, he's starting to get bad. Well, hospitals, man, you can't survive in hospitals. You get bad.
So this one's it's just a quick little look at your isolation rooms. We got to put a box in here to demonstrate there's a little Phoenix valves on these things. All those Phoenix valves do is we send it a set point, and then it controls to it. They're a third-party VAV box that we really don't control. I don't know if you've ever seen a Phoenix valve. It's kind
What
of
is it? What does it do?
Somebody told me
Oh,
that
sure. I got it on the operation rooms.
he actually.
So this is it right here.
I think said
It's
something
kind of
that
like
was really
it's like a
useful.
toilet plunger almost, and it's like a
So, I mean, that's a
Like a
lot.
diaphragm?
it's like a valve. So what it is it'll go down to a smaller area and then open back up, and then that little area is where the valve will go in and out of, and it'll always maintain the same flow through that valve no matter what. They're like engineered so that like when these boxes are 50% open, they're always doing their right CFM. They're never wrong.
I guess he's been moved
They're just
out.
really fucking expensive.
Yeah.
They're kind of weird. It's really weird.
What's the purpose?
For these, it's just to maintain always the same. Like if you use them on exhaust a lot, just because it'll always maintain that right
In the room.
flow
In the
So-
room?
out of the room.
Out of the room.
Remember James?
So
Not the guy that used to get drunk?
No.
What's what's important? Why is it important to have a constant flow out of the room?
Keep all the homeless people out.
it doesn't need to control. It doesn't
He was actually
rotate as much as a supply. And exhaust, you always want to have at least stationary compared to your supply. So your supply will always be your changing factor, not your exhaust. Once you have two changing factors,
I kind of see it. So it's kind of like back pressure. So
yeah.
so you don't want too much flow if it's blowing too much and then it's going escaping somewhere that you want it to prevent.
Right.
Okay.
So this is just kind of like a, as you can see, you still have your VAV box right here, and then you have all your room control right here. Same exact thing. We're gonna have to add the change on that. We get your room DP right here as well. So it tells you that between your negative patient room number 3,000.
Wait, who asked for it? To have the deadband instead of having both? Is that supposed to be, or did David ask for it? Or
David asked for it.
Okay. Because I was gonna say this is actually preferable to have both. Then we can adjust it, by yourself, right?
Yeah. I mean, if you really need to, what you can do is just set your cooling set point and then change your deadband higher.
He's somewhere else.
Well, whatever.
It's all preference, I guess. And I guess that's kind of what David
Sure.
wanted.
Yeah, I mean
Just
that's
cool.
what I thought. Like, because I didn't see anything wrong with that.
Yeah.
Work graveyard 7 days a week, man.
Oh, wow.
So here, this
Month
occupancy.
in, month out.
It's like a sensor.
No, this for the ISO rooms, it's just the box occupancy.
Oh.
Not that it'll ever go unoccupied because these rooms are always
okay.
this place is 24/7. The only place with aux sensors are your 4 ORs.
Okay.
These do not have aux sensors, which we'll see when we go to the ORs. But the way your exhaust boxes control is an offset of CFM from your supply. So right now your supply is
Oh yeah, he's still sleeping.
Vinny be passed out.
300.
I'll be knocking on the window.
You might wake up late.
Yeah.
6 o'clock.
Hold on.
He's KO.
That's the older gentleman, right?
Yeah.
Call him Steve's uncle.
Steve Richard.
We
He's pretty good.
we have to expose the set point, but you see the set point below the flow here, and what it is
James came to
so
those-
say like this one looks like it's about 320 is your flow set point. So we offset it up on the exhaust box by 75 CFM, so you make 395 CFM out.
He was pretty good
And
most of the
that
time.
way, you're always a negative.
Well, when it comes
And
to
no matter what that supply does, if that supply dips, your box won't stay, your supply box won't stay. So that way you're not generating a huge negative inside that room. You're going to keep that pressure the same as long as that supply box changes.
Some guy threatened to.
Got that?
Yeah, that makes sense.
Cool, cool.
And when the guy said that,
This little room DP is that set point.
big old
That's all
knot
that
raised
is.
up on his head and everything.
That box, right? That little white box.
That little white box, yeah,
Okay.
which you can get more of on the air
The
systems
guy told me, he said,
tab under room
"You're a
pressure.
scary guy. You're too fat. You got kind of
Question by, so it's pretty straightforward. So if you ever really need to like tamper with these, well, not really tamper, but you know what I mean.
Mm-hmm.
Like you can just, if you're not making it not negative, you can just change this flow.
Increase the flow.
The guy gave another
Bring it
one
up.
for that. Oh yeah.
So increase more negative
Correct.
in the room.
Yep.
He loved that kind of stuff.
Might have clicked this too soon. Oh, there we
He
go.
wouldn't do it
So
on
you just
camera.
change that to like
Mhm.
100, make it a little bit more negative.
Got it.
Cool. And then we'll go into operation rooms. They're like isolation rooms, but a little bit more fancy.
Mm-hmm.
Tried to print
Um,
some,
these
foresight,
ones-
something like that. It went to printers all over the hospital.
Does it show the negative pressure?
we don't have pressure
I
sensors
remember
on
him
these.
coming in with one morning, man.
These are,
Terry, I got
we have a straight exhaust flow and a straight supply
And you
flow.
just do, it's like one is smaller than the other, it should be a negative, right?
Yeah, that shit's just
You know,
kind of
I didn't
crazy
know a lot about
too.
the
Because like there's like 500 CFM that's made up off of
Terry tried to
another
get it off of there.
exhaust fan, so that's why
Christine
this
Lee
is
came
off
in.
of exhaust
She
fan
cleaned it up. After she
18.
had several, you know.
So
Yeah.
that's why that fan modulates, is because these
It's pretty
boxes
good.
can change to
Yeah.
open and close.
But
Um,
Brent found out like,
so looking at this,
like
it's the same thing. Here's your aux sensor.
Doctor was watching.
So the room is occupied based on the schedule, where your aux sensor's not
I
on.
think they weren't the only one. I think there was other
This is really confusing.
Everything. I think that stuff's all blocked out.
Oh yeah, you can't. You tap that up, it won't even let you go on there.
So as you can see, the aux sensor is on. Someone's in that room that's controlling. Also, they look like they probably hit the switch as well. There's a little switch on the wall. I don't know if we can probably look at that today,
I
but
think it was
there's
a pretty good guard.
a little box in the wall that we have to label. There's a red,
You
I
went back to.
think it's a green light, and a switch, and a horn. The switch is something they can click to manually override the occupancy if the aux sensor isn't working, and it'll override the space for 2 hours. It'll turn on the light as well next to it if the aux sensor or the switch is triggered. But there's a little horn, and I believe it's like 5 or 10 minutes before the space goes unoccupied, that horn beeps for like a second. And it kind of lets them know, like, hey, I'm about to go unoccupied, and they can go over and hit that button. Or jumping jacks, whatever they want to do.
I remember when.
Other than that, it's kind of like the same stuff with an isolation
So,
room.
if you don't hit the button and the system, it is occupied, would the light be on?
The light shouldn't be on.
Should not?
Yeah, I don't know what's going on here. I'll have to check the
He
back
said a
end
couple
and make sure
things.
someone didn't override this on.
Something
Oh,
was
this is
going
on.
on Terry there towards the end. But
on,
he does
too?
some medication.
This one looks like someone overrode something. That
No
shouldn't be
question
on.
about it.
It should say off if these aux sensor and switch are off,
Maybe.
and that everything should go off. Your supply airflow box is going to go to a minimum. Your exhaust flow
I
box is
think
going to
Terry
shut
was
completely, and that's right.
The one out of the
corner.
4 will still be on.
Yep.
And he was gone, man.
But otherwise-
Do we know which one that is?
I don't know off the top of my head. You have to look at
You sit down in that
mechanicals
seat
to
out
see
there,
which
you
one.
know,
It's
cement
yeah.
Is
Yeah.
it physically different looking or it's all the same?
They're all the same looking in the room,
Yeah.
but in the mechanicals you see that EF17 picks up one corner of each OR. Other than that, this controls just like a normal VAV box.
Mm-hmm.
This should look like this in the isolation rooms.
Okay.
So that's it. Any questions? Pretty straightforward, huh?
Dennis was okay.
It's hard to do training. Most of the time you guys need to play with it before you really. Yeah.
But, you know, I mean, as you're explaining it, if I can understand it, then it makes sense, then it's gonna, I'm gonna retain it, right?
Right. So, and these, pretty straightforward. A lot of them have a receptacle for power, as you can see here. This one's powering a switch that does all our network. This is your hot water system controller that's labeled. And then this one's your chilled water system that's labeled, and also has our schematics taped to them. We also have more on the door over here. But if you ever have an issue with these panels, there's this switch up here. If you open this switch by pulling this right here, it'll kill power to the whole panel. That's the way you can kind of cycle power to everything. Another thing is if you're having issues with power in here and you're having something that pops up, check all these fuses, make sure they're not popped. Yeah. If you don't want to do power to receptacle, there's a switch for this for some reason. Over here, this is what we call an automation server. That's an AS. AS9 serves all the mechanical here on the roof, including air handlers, chillers, hot water systems, steam boilers, as well as AC1. These are like the brains for each floor. We have 9 of them, so you have 1 on each floor. Yeah, 1 for the roof and then 1 for each floor. Pretty straightforward stuff. Everything always comes back to here, and it goes straight down to the basement where our
And they're all in the same spot?
Kind
each
of.
floor? Or kind of?
It skips each floor, so I believe it goes roof. I want to say it's 5th, 3rd.
So 2 on like
I think it's like 2 or something. The way it is, we have the locations on our prints. Not our prints,
But
on our.
what, I mean,
our as-built.
what would we ever need to go in there for to troubleshoot?
If one
Like
of
make
them
sure it's
are-
connected, make sure it has power.
So there's a status light. That's your link status light. This status light, sorry, right here. If this status light's ever blinking, it's either in startup. If it's red, it means it's failed. Sometimes the power cycle will do it. So what you're gonna do is just come in, hit that switch. Or what else you can do is these little green tabs on either side. You can pull them out. You just pull it out. Wait for the lights to die down, and you just push it back on, and click it back into place. It'll blink, and eventually it'll go solid. Once it's solid green, it means it's up and running and good. Any other state's not good. Same thing. Power supply, voltage receptacle, pretty standard stuff. We'll go check out our air handler one.
Yeah.
So this is the air handler 2. All air handlers look the same like this. Same exact thing. Here's a fuse block right here for our 24 volts. If you're ever not having 24 volts, you want to check the fuse inside of here. You just flip this little door down and you just pull it out. Same thing up here. There's a little fuse, a little switch. Open that, kill power to everything. Our power is up here. Voltage receptacle. Pretty straightforward stuff. Underneath here is kind of hard to see with the light, but these blinking lights, there should never be any red lights. There should never any red lights under those lights. Solid green's good. A blinking green, another blinking green and a blinking orange is also good. It means it's sending and receiving signals. But we're pretty much taping this stuff inside of the doors for everything. Kind of rough hand. Some of these things have changed. But I mean, at least for now, you guys can reference this. Yeah, that's it.
All right.
For our panels.